Hi there, folks. Root Beer here, as usual, and I'm going to be starting another math contest. This time it's going to be from the year 2019, and it's going to be one of the Manitoba Math Contests. So this is a high school level contest. It's aimed at students in grade 12, as we can actually see here. I've got my copy of the contest. So here's what they look like nowadays, and you can notice a couple things. It is for students in grade 12. It's written, I believe, the same day as the Pascal, Cayley, and Fermat's. Gives math students in grade 12 something to do that day, I guess. You've got 2 hours. There's only 10 questions on it, and they increase in difficulty, as with most math contests. And it's good. If you can do well on this, I believe you get offered some scholarship stuff at University of Manitoba, I would guess University of Manitoba, because they're one of the sponsors there. But it's a good paper to write. I find it's a little nicer and neater than, say, the Euclid contest, which is also aimed at grade 12s, but it's made by the University of Waterloo. So here's what it looks like, sign in and all that stuff. But here's what we care about, instructions and things like that. I'm going to let you read that if you're interested in it. If you are writing a contest this year, any contest, not necessarily the Manitoba contest, it's always a good idea to read instructions from past contests so you know what you're getting into. Our calculators are allowed, how much time, what sort of information do I need to provide, that sort of a thing. What will be given to me, what aids are available. It's important to know, but I'll let you read it there. Well, the thing I'm most interested in is no aids are permitted. So no calculators is probably the most important part. No calculators at all. But they don't even let you have compasses or straight edges or anything like that. I honestly don't know why. I don't know what you could do with straight edges that they don't want you to do, but so I guess no rulers allowed. But there you go. And if you would like a copy of this contest, you can click the very first link down in the description below, and it will get you a copy of this 2019 paper. I'm going to go through the questions one video at a time, so this video will be dedicated to just doing a question number 1. Next video, question 2. So if you get a copy, again, click the very first link down in the description, and you try it out and you say, gosh, I couldn't do question 5, feel free to skip ahead. Join me for question number 5. You're not hurting my feelings. But with that said, let's get into question number 1. I like the booklets. They give you a lot of space in these booklets here. All right, so question number 1. Question 1 there. 2 parts here. First one looks like an inequality. Question 1, find an integer n satisfying. All right, so n over 6 has to be between 3/7 and 4/7. Okay, 3/7 and 4/7 are sort of on either side of 1/2. So if I were to let n equal 3, 3 over 6 is 1/2. That you could probably spot your way to an answer there, but we do want to be showing our work. It's question 1, but we want to get in the habit of showing our work. So what could we say here? How could we explain our answer? Well, it's kind of hard to compare fractions that don't have a common denominator. So multiply everything by 7 and everything by 6, or make them all fractions over 42. Doesn't matter to me. I'm going to say multiply by 42. That's just 6 times 7. And so you'll get 18 up here. You'll get 6 and 42 leaves the 7, so you'll get 7n and 24 here as well. Okay? If you're not happy with that, leave it as fractions over 42, and all you did was find a common denominator. But I prefer integers over fractions myself. So I'm just going to multiply everything. Multiplying by a positive number, the signs don't change. You don't need to point that out. Now, if n is an integer, then 7n is an integer. We're looking for an integer that's multiple of 7 between 18 and 21. So 7n equals 21 will work. And then you can see n equals 3. That's it. Not a whole lot required, but we've shown our work for it. And there you go. Okay, B part. Will, Bob, Sarah, and Ida wrote letters on the blackboard. Wrote integers on the blackboard. Bob's number was 15 less than Will's number. Sarah's number was equal to the square of Bob's number. Ida's number was 1/2 Sarah's number. If Ida wrote 72, what possible numbers might Will have written? So they wrote integers. They might not have written positive integers. And I noticed there was a square in there. Okay, so here's what I'm going to do. I'm going to set up a few equations. I'm going to let B be Bob's number, W for Will, S for Sarah, I for Ida. Okay, so what are we told? Bob's number is 15 more? Bob's number is 15 less than Will. And nice simple equation. So if Will wrote down 16, Bob wrote 1. Sarah's number was equal to the square of Bob's number. And then Ida's number, which we later find out is 72, is 1/2 of Sarah's number. All right, so there's all three conditions. There we go, and then we're told I is 72. So what we've got is 72 is I, which is 1/2 of Sarah's number, but Sarah's number is Bob's number squared, which is Will's number minus 15. Okay, multiply both sides by 2. We'll get 144 is W minus 15 squared. So what numbers can I square to make 144? Well, 12 or minus 12. Now, if I add 15 to both sides, I see Will's number is 27 or 3. Okay? And there we go. 27 or 3. So Will did have different possible numbers, and it did come about from this square here. But that's it. And they're not trying to make question number 1 particularly difficult. I mean, one of the sort of things to shoot for if you're making up a contest is to make question 1 something that just about everybody who's writing will get. Okay, so they're not trying to make anything hard. Nice little fraction question, and then just a can you follow the series of instructions backwards question. Very nice. So that was question number 1. Up next will be question number 2. Feel free to join me for that if you'd like.